Okay, a question was asked about how to convert a chair conformation into a Newman, or how you look at a chair conformation in a Newman projection. So I have a picture of a Newman projection over here on the right, and let me go ahead and draw out what that chair conformation would be, like so. And so what I'd like to do is I'd like to be over here in the molecule looking down those two carbon-carbon bonds. Let me go ahead and put those in red. So I'm going to look down that carbon-carbon bond and that carbon-carbon bond, which would correspond to being over here looking down that carbon-carbon bond and that carbon-carbon bond. Okay, now if I'm going to do that, I need to basically take these two carbons here and here, and I need to put them into Newman projections. Let me work on the carbon here that's in the back, but as I'm looking at this, this would be the left. So I'm going to look at the carbon-carbon bond that's on the left. Well, what you can see is we have an axial position, we have an equatorial position here, like that, and then we have, and those are our two carbons there. Then looking at the back carbon has an equatorial position here, and an axial position down, which would be here. So I'm going to just make that more equatorial. Okay, so if I'm looking at my hydrogens here, let me go ahead and color code these with green first. So here is my back green carbon. Don't try and write green on a green background. So how about let's make it light blue. I'm going to have that as my axial, or as my equatorial position. That would be this hydrogen right here. Then if I go to a different shade of blue, this would be my axial position down, which would be that hydrogen right there. That's on the back carbon. On the front carbon, I would have let's go with the pink. I'd have a pink hydrogen up here that's now axial. That would be this one. And then the equatorial position, we'll make it purple, would be this hydrogen down here. And so that would be that hydrogen. Okay. So if I'm looking at this, if I'm looking at the top hydrogen, or down the top carbon-carbon bond, I'm seeing hydrogens that are in the front and the hydrogens in the back. So I've kind of color-coded those. Now let's draw that out down below. So if I draw it out down below, here's carbon 1. I'm going to call these carbon 1 and 2. So the front carbon here is going to be in this kind of Newman projection. It's going to be staggered. So let's put the atoms around. Let's start with purple. So the purple atom is on the front equatorial. Here's the front carbon. There's where the purple hydrogen goes. The pink, which is axial, would go here on the front carbon. And then looking at the back carbon, we have the equatorial, which is the light blue, would go here on the back carbon. And then if we look at the darker blue that's axial, it would be that one. So looking at this, looking at all of these, that's how I would look down this carbon-carbon bond. And so I would see those Newmans. So I see these hydrogens in the front, hydrogens in the back. Now, what's going to be over on this position and this position? Well, if you follow that down, what comes down here, that's where the CH2 group is. So this is where the front CH2 group is. And then in the back carbon would be the CH2 that's up. So that would be the back CH2. So if I'm talking about this, I'm just going to label this 3. This would be carbon 3. And then that would be carbon 4. Okay. Then if you follow that through, and now let's look at the other carbon, the one that's closest to us, the one on the right from my perspective over here, that carbon is going to basically be attached. I'm going to have a Newman projection there. I'm going to have an axial position up and an equatorial position like that. So that axial position up, equatorial position out of the ring. This bond right here is down to the CH2. So it would look like that. So looking at the front carbon, we would have an H here, which would be this H, axial. And then we would have an H over here, which would be that hydrogen. So again, that's attached to the front carbon. Looking now at the back carbon over here, and looking at this carbon over here, we now have axial down, equatorial out of the ring, so axial down, equatorial out, and then the other bond is up to the CH2, which would be that one. And so looking at those hydrogens, which I need to give another kind of color, give it a light, this hydrogen, this light green hydrogen would be the one here, and the orange hydrogen would be the axial hydrogen down, which would be that one. So the idea here is I'm looking at this, I'm looking down the left carbon-carbon bond, the right carbon-carbon bond, and what I'm seeing is I'm seeing 2 axial positions on the front carbon up, which is this and this. I'm seeing an equatorial to the left, equatorial to the right, equatorial to the left, equatorial to the right. And then I'm seeing the CH2 attached to those 2 carbons, which is these. And then on the back carbon, we've got the CH2 up here, which is carbon 4. Then on the right carbon, we've got axial, equatorial, axial, equatorial. And on the back carbon, equatorial, axial, equatorial, and axial. So this would be my view of the molecule from looking at this perspective. Okay, and looking at the molecule over here from that perspective. So let me just show what it would look like in the rest of the pictures. So if I change this kind of cylinder model to ball and stick, to what's called a ball and stick model, it would look like this. Again, my perspective is looking down those 2 carbon-carbon bonds. And if I did that, that's what my viewpoint would be, looking at the front carbon. Here's the front carbon on the left. Here's the front carbon on the right. The axial and equatorial positions, axial and equatorial positions. Then from behind, we've got the carbon, the hydrogen down and to the left, to the right and down. And then we have our front CH2 and our back CH2 in the upper position. So if I don't know if I can do this, let me select all of this stuff. Which it won't let me do. Let me lasso select all that. copy it, and then come down here and paste it, and then so you can see that this view right here is very much looking like the front view over here. So that would be my attempt at trying to show you what the Newman projection would look like for the chair cyclohexane, looking at it from the left-handed perspective.